So the theme of this session is to explain what we've done at a customer working in pharmaceutical in the Basel area on AWS. Now operate their data center, which is mostly running in AWS cloud. So a few words about me. So I'm Nicolas Jardot, a senior consultant at DBI Services. I work for DBI since 9 years. It was my work birthday in beginning of the month. So it's been a long time. I started as an Oracle DBA and switched since the last 3 years, working mostly in AWS cloud. So I'm now a certified solution architect. But let's go straight to the point. So I'll briefly introduce AWS, but Matthias already told some stuff. So then we can move to this infrastructure as code. Then the patching management, because we saw that security is part also of what customer needs to do in AWS, and then a short conclusion. So as an introduction, what is AWS? So I think I won't spend too much time on it because it's the most known cloud platform, and we all know that it's related to Amazon.com. There are, as of now, 24 regions, and as Matthias said, a new region is coming to cover Switzerland, so we can keep the data here. That would probably be a good point for many customers. How does it work when you work within AWS? So you have all these regions that Matthias spoke about. Here, in example, the region in Frankfurt. Each region is composed of availability zones. The minimum is 3 zones in a region, not less. So you can have some redundancy, but you can also have more in the biggest region. And each availability zone is composed of one or many data centers. So physically, in the end, the workload will run somewhere physically in one of those data centers. We also saw that there are more than 160 services. So in 45 minutes, I won't be able to speak about everything. And customers are not using all the services. You need to pick what fits your need. So I'll focus on the main services we are currently using. So the most basic one, the VPC, Virtual Private Cloud, it's how, as a customer, you take a piece of AWS and you create your own network on top of their infrastructure. So there you can decide which is your IP range, create your subnets, decide the connectivity between the subnets if you want to have multiple VPC with different IP ranges, how you connect them together or not connecting together if you want to create secured zone or stuff like this. Then one of the other well-known service, because it's kind of the base of what we do in IT, we need some compute, Amazon EC2, Elastic Cloud Compute. Here it's basically if you want to run kind of a VM in the cloud, so you can start Windows or Linux or vendor appliances on a compute where you choose the shape. So you choose an image, which is called an AMI, and then you start the machine. And you can then decide to pay as you go, because you are in a proof of concept mode and you want to know how it works. Then you don't commit on anything. It runs on demand. Or you can also, as Matthias explained, commit on usage for several years, from 1 to 5, and then you can make huge saving on the cost of running this infrastructure. Then everything would need after compute is mostly storage. We all know that in the last years, the data expansion is quite exponential. There is more and more data to store, to process, to analyze. So here I focus on the 2 main storage services. So EBS, Elastic Block Storage, which is the storage you can attach to EC2 instances. So it's like having a bunch of disks or replacing your SAN in the cloud. So you can create volumes, you attach the volumes to the EC2 instances, and then you can consume that volume. Here, AWS is providing different type of storage, so you can use SSD, you can use provisioned IOPS, or you can use more cold, like old-fashioned hard drive to save the price. So it's a balance between the price and the performance you want to know. On the other hand, there is the block storage, Amazon S3, which is well known because that service became a kind of standard. So some AWS competitors are now using the same API to be compatible with S3. So in S3, you don't have this concept of attaching a disk somewhere. You are just working on the object level. So you have a video, you have a text file, an Excel sheet, you have some packet file to process, and so on. And the good point of S3, you don't have really to care about how it's stored, or you just run through the API, you store the object, and then AWS is guaranteeing you that you will retrieve this object with a 99.999. I don't remember the number of nines because it depends on your storage class. But then you don't have to worry how it works. You just consume the storage from AWS. On the cost on that side, there are also several options because you can choose to store on the standard class, or you can say also the data is for archiving, and then you have different archive class where the cost per gigabyte is reduced. You can also use intelligent tiering, and you can create some lifecycle rules. That's could be a topic by itself. So let's continue. How it works on most customers. So as a customer, you register to AWS and you open an account. So that's what we can show here. And then within your account, you can decide to work in a region or in multiple regions. But if we focus on one application or something, then you decide on which region you want to run it. It could be close to your location because you want to have the data close to you. It could be that you have an application which is consumed by someone else. Then you can try to run the application in a region close to your customers. It's totally your choice. Then we saw the region is composed of about AZs, and you can create VPC, one or multiple VPC, to create your network there. And then once you have everything, you can start to say, okay, I want to run some resources in the first AZ. I want to run my database in the second AZ. And you can build your application like this. So let's move on to the core of the presentation, infrastructure as code. I'll start to say how we can manage resources in AWS, and then I'll go on how it works at a customer for provisioning and configuration. And of course, I'll try to show a demo that won't be exactly what we use, but that is really showing the spirit and how they work with AWS Cloud. So how you can manage resources in AWS. So the most obvious way of doing it is just to use the console. So you just need a browser, you log into your account, and then you have a graphical interface where you can just create resources, stop them, destroy them, create new resources. And the good point on the console, especially when you are discovering services, is you have a lot of wizards. So you can find some buttons like this, launch a virtual machine or build a web app. And then you have some steps that appear. So let's say I clicked on launch a virtual machine, and then we see that we have 7 steps to start our new virtual machine. So first we choose an AMI, then we can choose an instance type, to configure it, configure the storage, the security, and then we are able to start this new machine. So console is really when you want to see the different options you have, discover how it works, use the wizards to get some help and tips to start something, mostly if you want to do a proof of concept. But then that's not the easiest way to do because everything is manual. So then when you move to a more advanced way of using the cloud, you can say, I want to use the command line interface, the CLI. Because here you can say, okay, I can script to create new resources. I can do some batches to run changes on resources, to stop them, to change the instance type, or I want to do some kind of reporting, so I can use the CLI to get the data about my resources, so how many instances I'm running, what types they have, and so on and so on. And this is quite easy. It looks like this. So the AWS CLI then just creates a binary of AWS for you, or a command AWS. Then you can just run AWS. For instance, here I want to create an EC2 instance, as in the previous slide. So here, AWS EC2 run instances, and then you just provide the parameters you want and the minimal parameters you need to execute the command. So here we see that I choose an AMI, then I choose a key pair to be able to connect to the instance, an instance type, the subnet where the instance will run, and a security group to define the open ports to access the instance. And that's it. And after you run that kind of command, then AWS is giving you back an answer. So here the answer is truncated, otherwise it does not fit into the slide. But I took the most important fields. So here you see that you can get private IP. And here you notice that the IP 172.28 is one of the private IP range. So that IP is not visible on internet and can't be accessed as this on internet. So I really created a machine which is private for me. And then I can address it with the instance ID. So that's one of the good way of creating resources. But then you still need to script, adapt. The scripts will work for AWS. And in the background, how the console and the CLI work, basically it's because the cloud, at least my interpretation of cloud, is having an API to manage the resources. So everything you do with the console or with the CLI is in fact calling in the background for you AWS APIs to create, manipulate the resources. And the API is documented, so you can decide to use directly the API to create resources. So it enables you the fact that you can create application that creates infrastructure, or application that can self-extend because they want to run something. Let's say you process images. At some point, the application, you have front end and back end, and you are just grabbing images. And then the application itself says, if I reach that number of image, I can spin up a new instance, then to process all the images and then stop it. So you can scale automatically from within your application. So here, if I take the same example as the two previous slides to run an instance, we see that we call the API ec2.amazonaws.com. Then you pass the action you want to do and the parameters. So again, an image ID, and here subnet, network, all that stuff. So that's how very quickly and very brief, how you can create resources in AWS. And everything is managed through the API. Can be a bit hard to work directly on the API because you have to manage the way to authenticate to the API. You need to read a lot of documentation to understand the API and the parameter. But then you still want to move to this infrastructure as code spirit. And why do you want to move to that way of provisioning? It's quite simple. There are many advantages because you can create versions of your infrastructure. So for one version of the application, you can have also one version of the infrastructure that creates or runs this application. So if the application evolves, then the code for the infrastructure can evolve as well, and you can find all that story within your code. We mostly see people using Git, but you can use any versioning. You can also say, I don't want to use versioning because only the latest code is okay for me. But that's something that is interesting to see how the infrastructure is evolving. One of also the good points is if you have code to declare the infrastructure, then you have the first part of the documentation which is done. Because if someone is creating something manually, then there are plenty of reasons that that resource may disappear from the documentation because someone forgot to add the machine into the Excel list, or there was an update to people concurrently change the file, and then we don't remember. We have to go to the inventory back. So the code itself is kind of self-documenting your infrastructure, so you know all what you are using. The other maybe the biggest strength of the code infrastructure, you can repeat deployments because many applications are very similar. So you know what you'll have to deploy. And then if you have the code to do it, and you can create kind of modules and you can repeat the deployments. And then it brings you into this DevOps philosophy and the continuous delivery, because you have code, then you can create a pipeline to check that code and apply that code to create the infrastructure. So here you have different options. You have the one directly from AWS CloudFormation, Terraform, Cloud Foundry. So here I'll put the focus on Terraform because that's what we are using at customers, and we'll see why here. So Terraform has different offering, but Terraform is at first an open source tool. So you can just use Terraform open source, download it. It's a single binary, which is very, very light that you can run from almost anywhere. And we mostly use Terraform to work with the cloud, but Terraform is just a kind of interface between you and many providers, and not only cloud providers, because there are providers to manage VMware or DNS services. So you can basically any infrastructure, you can describe it in Terraform and then manage it through code. And one of the cool points of Terraform, if you already have an infrastructure, you can just do it in a reverse way, create the code that describes what is already existing, and then import that configuration and link your current infrastructure with your code. And then you can start to manage this infrastructure through the Terraform code. So one important point of Terraform, so we see as an input, you create what they call here policies. Then it calls providers that creates the infrastructure through the API for you. And then you have an output, which is mostly what Terraform calls a state file. And that file really reflects what Terraform deployed for you in your cloud provider. So that file, I strongly recommend to store it in a shared location. So for AWS, that's the kind of file you can put into S3. So then we will move a bit on how Terraform works. So there are four main operations you can do with Terraform. So that's quite simple to understand and manage. So the first one is the init. So during the init phase, Terraform will download the providers. So you can write some Terraform code to create resources in both AWS, Oracle, or Azure Cloud. That's not a big problem because the providers are existing, and then you can just target the environment you want. You just have to describe it into the code. Then during the init phase, Terraform will process your code, see what provider you need, and download them for you. So you can then run and use the API. And it's at that phase, it also initializes the state file. So here you need to have a code which is valid. Then you can just run a Terraform plan. So during the plan, the important stuff to remember is Terraform won't change anything. So during the plan, Terraform will just query the API, look at your code, and then show you what will be deployed. So here we will see it in the demo. You have a very clear plan saying how many resources will be created, updated, or destroyed. So the destroyed may be frightening, because yes, Terraform can destroy resources. And that's very important, that between the plan and the apply, there is a review of what's going on, because that's the step where you can see, oh, there is something wrong. Someone removed an important resource from the code, and then Terraform wants to destroy it. So then we need to go back in the past into the code and bring back that resource before we apply the code. Could happen if different people work on the same project. And then you go to the apply phase. So once you are happy with what the plan said, so it will just create resources or update the resources, and the output shows that it goes the way you want, then you can just do an apply. So the apply is kind of two-step operation, because if you haven't done plan first, apply will do it. And then we'll just, if you run it by default, prompt you for an approve. But here it's to remember, apply is the function that change stuff into the cloud. So here resources may be created, destroyed, updated. Basically, if you create resources, it's at that point you start to pay for your on-demand resource. And during the life cycle of an application, then you may reach a point where the application is moved to another infrastructure, or not needed anymore. Then you want to destroy. So the good part of having the infrastructure in Terraform, if your Terraform code describes the whole infrastructure of your application, then you can just run a destroy to remove all the infrastructure for that application. Then there is normally not leftover or anything, because you described everything you need. So then when the destroy will run, it will destroy everything. That's the operation we usually don't do. At least for now, we are mostly creating resources than destroying. But the thinking about decommissioning when you create resource is also very interesting. So that part was kind of purely for provisioning. So now we need also to configure the resources, because you have probably naming conventions for the server, you have internal DNS, you have some security rules about the firewalls. You want also to take backups of this infrastructure or to monitor it. So then all that configuration can also be done through code. And the biggest advantage is the consistency, because if you run the same code over all the machines, then you ensure that all the machines are configured the same way. So there should be no machine where the monitoring agent is not installed. And again, here, versioning can be very useful, because you notice that at some point in your configuration code, something was forgotten and needs to be applied to every machine. Then you create a new version and you apply it again, and then you are compliant. So there are different alternatives. Here I've put the Microsoft one still in the list, because for me it's one of the configuration tools, if limited to Windows. Because here you can create packages, deploy GPUs through the domain and all that stuff to ensure the machine are configured. But we'll focus more on the kind of new tools that appeared on the market after, like Ansible, Chef, Puppet, and Salt. So Ansible is well known because there is no agent, and you can configure. You just create code, run it from a control host, and it works. At the customer we are speaking, we are using Chef. So Chef, like Puppet or Salt by default, needs an agent to be installed on the machine you want to control. So let's move on a bit on how Chef is working. So Chef has many components. You have the Chef client. So the Chef client on top here is running on the resource you need to manage, which is called a node. Then the Chef client speaks with the Chef server through an API. The Chef server is a kind of the central location where you store the configuration and the metadata about your nodes. So here we see that there is this bookshelf and the cookbooks. So the cookbooks are the configuration units you will use on your Chef client. So the Chef client will just go to the Chef server, ask, okay, I'm running on that node. What should I do? And then the Chef server will look at the metadata and say, you need to run that cookbook. And then the Chef client will just say, okay, give me that cookbook and I'll run it. So here, that's just a recap of what I just said. So the node in Chef words is the server we want to manage. The Chef server stores all the cookbook and all the metadata about the server we manage. So here you can create roles, environments, you define the run lists and all that stuff. The Chef client is the agent running within the node. So it's installed on all the nodes and it registers the node to the Chef server. Then the Chef client is responsible for maintaining the configuration for you. So the Chef client has to run on the node to apply the configuration. And the cookbooks, then there are the code itself that contains the configuration you want to apply. Let's move to the demo, which is the most interesting part. So that's how it will look like after the demo. So I already prepared through code, obviously, a region, a VPC where I have a public subnet, a private subnet, and I have a Chef server. And the goal of the demo is to deploy a web application cockpit in the private subnet and a load balancer so we can access that application. So how the code looks like, it looks like this. The Terraform code is quite simple, not as simple as some people think about Ansible, but it's still quite self-explained. So here we see that we want to work with AWS and we want to create resources. So here, for instance, I create a security group. So a security group is kind of a logical unit which will act as a firewall in the AWS cloud. So you decide which ports are open or not to reach your resource. So that security group is called ELB because it will be attached to the load balancer. And we see that we open the HTTPS ports to the internet. And that's the point because the load balancer will be publicly accessible. And if we look at the security group of the instance, so here we open the port 22 because it will be a Linux instance and we need to manage it. But here we say that resource can be managed only from within the our network. So that machine won't be accessible from internet on the port 22. However, the application cockpit is running on the port 9090. And that one we said, okay, we open that port and we accept the traffic from the security group, the one we just see just before. And then we create our resource. So here it's the load balancer. So I said, I've opened the port HTTPS and I'll forward the traffic to the port 9090 and I'll attach it to my resource. And then here I create the resource. So let's see how it looks like into Terraform. So here I'm in my project. So in the web server, so here I can just do Terraform plan as we saw. So here Terraform is just checking if the resources are existing or not, and then it gives me back a plan. And here, that's what Terraform says it will do. So Terraform said, I'll create resources, and there is no update or destroy at that point. So I'll create an ELB, and we find what we just saw in the code. So I'll listen on that port HTTPS and go to 9090. Then I create an instance and with a bunch of tags. So let's just apply that code and see what happens. So here I'm using the auto approve because usually that's the kind of stuff that will happen through a CI/CD pipeline. So we run it through Chef Automate workflow. We have a manual approval between the plan and the apply. But once we hit the approve button in the CI/CD platform, then the CI/CD platform is running the apply auto approve. Let me maybe zoom a bit because I'm not sure that everyone is seeing the code correctly. So here Terraform is exactly doing what it says. So he said, I'll create 4 resources. And here we see, okay, it's creating the security group, the other security group, creating the instance, and then creating the ELB. And that's it. Terraform said, I created the resources. So now we can have a look into the AWS console. So here we see that I had a Chef server running already, and then I have a new resources. The cockpit machine has been created. So it's still in initializing phase because it takes a few minutes for the OS to start and run all the stuff. But here we see that the configuration we choose about the VPC, the subnets, and on the security parts, the security group has been created, and it really opens the ports we choose. So now it takes a few seconds to have everything back. So I'll go back to the code and speak about the configuration phase. So here it was just the Terraform part, but where the Chef part is coming, it's coming here. So when you start an EC2 instance, you have the option to pass user data. And within the AI, there is a Cloud Init software which reads the user data you pass to the EC2 instance to do the actions you want. So you can pass pure PowerShell or Bash scripts, but you can also use Cloud Config modules. So here I just say, okay, I want the host name to be set, the time zone to be set, and the Chef clients to be installed for me. So here we see that I want to address a Chef server. So here I'm using variables, so the code is modular. And I say I want to execute the cookbook, which is called web server. And then I have the code right here. And if we look at that code is quite simple. It's recipes, and the recipes just describe what we want to do. So it's a very basic application. So here I just say, I want to install Cockpit, and then I want to enable the Cockpit service. If we look at Chef, how it looks like, then now the machine has been started. There should be my new machine called a minute ago. So now the process worked automatically. So I've created a resource with Terraform, and now my machine has been registered to Chef. And then we see that it tried to run the web server cookbook. So on the machine itself, you can find some attributes. So the attributes I decided to create, like the APP1, and plenty of attributes that are computed automatically by the Chef clients. So like the machine ID, the host name, the CPU configuration, all that stuff. And there are some EC2 attributes because the Chef client can recognize you are running on AWS cloud. So now if we just go to the load balancer, the load balancer has been created, and then we see that the instance itself is considered as in service. So it means I can just take the load balancer IP or DNS. It's advised to use the DNS name instead of the IP in that case. I have no certificate, and here, oh, my application is working. So I can log into the Cockpit application. So by the way, the user has been also created through Chef. And here, my web application is working. Maybe I need to zoom. And now it's live. So I just created a very simple application in 5 minutes through code automatically. Here we can see that I chose this application because then I can open a terminal. And here, Chef Client has been installed. So now I have not so much time left. So I'll move to the patching management. So why patching? Patching is related to security. Patching became so important to me and to most companies after this crisis of WannaCry, because people realized that the patches were available, and since they were not applied, some hackers were able to use that vulnerability to harm some companies, and it had a huge impact worldwide. So patching became very important to everyone, and now you say, okay, I need to find a way to apply patches consistency on all my infrastructure, both cloud, non-cloud, maybe multi-cloud. So here we decided at that customer to try with AWS System Manager, that we call the SSM, because one of the strengths of SSM is you can manage Windows and Linux, and not only just Linux, because you can manage multiple Linux distributions, the Amazon one, CentOS, Red Hat, Ubuntu. So most of the Linux you can find in your company, you can manage them through SSM. And SSM can also manage your on-prem server. So you can have a single source to apply the patches everywhere. To work, SSM needs an agent and some holes on your EC2 instances. The thing is, it's already pre-installed on some machine. You can start into AWS like Windows Server or Amazon Linux or Ubuntu. So SSM is not just for patching. So this is all the stuff you can do with SSM. Like you can do some application management, you can store parameters, you can automate change. You can manage the instances and the operation with some dashboards, Op Center, and all that stuff. And here I'll focus only on the parts that we need for patching. So for patching, you have the patch manager. And within that patch manager, you can create patch baselines. So the patch baselines define what patches you want to install on your instances. So here you can just restrict and say, I want to install only critical and security updates, or I want to be really patching everything. Then you need patch groups, because the patch groups is what links some instances to patch baseline, and basically says to SSM when it's running on one instance to which patch group I instance can be member of only one patch group, but the baseline itself can contain multiple rules for the different type of patches. It's managed through the tags you have on your instance. We'll try to see quickly into the console. Then you need to run commands remotely on the instances. So you use the run command, and run commands needs some documents. So the documents is JSON or YAML code that describes what you want to do into your instance. And AWS is providing one which is called AWS Run Patch Baseline. So that document performs some compliance and patching operation on both Windows and Linux. So there are two operations. You can scan for compliance and then install to deploy the patches, and you can choose to reboot or to wait and organize a reboot by yourself. And then you can bring all that stuff together into maintenance windows. And then on maintenance window, you register the targets you want to patch, and then you can define a schedule and the different tasks you want to do. And one of the main tasks will be run that document patch baseline. So here within the maintenance window, we use it for patching, but you can use it to update the agent itself, to execute some scripts, apply the patches. You can also deploy applications, and basically whatever you want, because you can also create your own custom documents. So let's go back to our application. So here I have the application. It's running the Chef client. And if I go to the code itself, something you haven't seen, because I haven't showed, is the Cookbook web server has two different versions. So I have a version 0.1, and in that version, I was not installing the agent. And on the version 1.1, we are installing the agents. And how I managed it? So the environment here for production, I said, okay, we stick to the version 1. And that's how at that customer, when we have a new cookbook version, we ensure that the cookbook is just not deployed everywhere at the same time. So we just move some constraints. So here I'll update the constraints and say, you can install on test the version 1.1. So here you need to run the Chef client. So that's part of your CI/CD platform. Then, which when the code is updated, then you go through the approve, and then you just change the constraints automatically, and then you run automatically the client. So here we see how a Chef run looks like. And here we just see, okay, it's changed the version and then detected that the agent is not installed and installed the SSM agent for me. So what it means for my patching demo, now I have the machine which is managed through SSM. So if I go here, I find my instance, my web cockpit, which is here. And for now, I have no information about the patches. So what I can do very quickly, I can just run a command, say I want to run the patch baseline. So here I will just scan it to have a report on the compliance and see how many patches will be installed, because otherwise it takes a few minutes and we are already late. I'll just disable the write to the output, and here SSM is then running this AWS run patch baseline document into my instance, and now it's succeeded. So what happened if I go back to my instance and then I see to the patch, then SSM reports, okay, I already have more than 203 patches and there it's needed. So I need to move fast for the end of the presentation. Now I'll jump to the conclusion. So infrastructure as code on that customer case, what have been achieved so far? So all what you've seen on the Chef code and Terraform code runs through a workflow, provisioning workflow, which is JXP, allows us to deploy JXP machine in Chef Automate. The code is stored in Bitbucket, and that code is a combination of Terraform and Chef code. So Terraform code provisions the infrastructure and then starts the configuration with Chef automatically. And as it's pharmaceutical company, then we need to have IOQ testing, and we use the output of Terraform and the Chef inspect tests for documentation. And all of this requires manual approval to push changes to the real prod environment, create the val and prod machines. So the advantage is the provisioning is now standardized. So we have the same way of provisioning all the machines. The code itself is quite easy to read, and it reduces a bit the documentation we need to do, because there are very few or even none manual steps. So you just run the workflow and then you grab the output. One of the drawbacks is Chef itself requires its own infrastructure with few servers, and it can be a bit complex if you want to do very simple changes like just updating a tag into the instance. On the other hand, you can also say that tags are not managed to Terraform and just ignore them when you do another plan and apply. About the SSM part, what has been achieved to the customer, one of the last patching, more than 200 EC2 instances across 3 zones have been patched. And in the same, there were also 32 on-prem instances and VM that have been patched. And now it ensures the patch for test and production are the same. So if we compare to the manual process that was in use in the some instances were not patched as regularly, So on the management level, the reboot was not communicated as an official maintenance window. So we had to discuss with every system owner. So it was not possible to apply the patches in one day. And now with SSM, it's something that's. But then there are still some open points because the way SSM works, we can't have maintenance window across multiple accounts. So we can with run command, but not with the maintenance window. So for now, we still have SSM configuration split in different AWS accounts. So then one of the next point is trying to centralize everything and have a single inventory and reduce again more the administration effort. And maybe something that could be useful for the system owner is to have an email at the end of the operation. So that's still something we want to work on.